This is the back side of the H2-4 notes on changing quadratic functions in standard form to quadratic functions in graphing form using the process of completing the square. So our first problem that we have here, we have y is equal to 3x squared plus 12x plus 1. Now this one's a little different here than the ones on the other side because we have this a value that is 3. So to do this, we're going to start out by completing the square, but we have to get our equation set up to be able to do that first. So first step, exactly the same. Subtract our 1 from each side. We're going to get rid of the c value there. So we have y minus 1 is equal to 3x squared plus 12x. And now, because we have this 3x squared, we can't complete the square because it's not going to be a perfect square trinomial with a 3 there. So this is the new step. The new step here is going to require us to factor out this 3 from the expression. So when we do that, we're going to have a 3 times the quantity of x squared plus 4x. Right now that still equals y minus 1. So I just factored that 3 out. Now this expression x squared plus 4x, right, we've got two terms there. We want to make that a perfect square trinomial like we were doing on the other side. So we're going to need to add something in. So we're going to have 3 times the quantity of x squared plus 4x plus blank right now. And if we add something to that right side, we know that we're going to end up adding something to the left side. And just a recap of how we've figured out what this missing value is right here, right? If we could think about it as a generic rectangle that we've been using for factoring there, we would have had our x squared here, and then we would have had to have taken our 4x and split it amongst those two quadrants of our generic rectangle. So in this case here, we've got 4x's, so we'd have to put 2x here and 2x here, which would then give us x plus 2 and an x plus 2. But we still haven't completed the square yet. To complete the square, we'd have to do 2 times 2 would give us 4. So the value that we would need to add in to our expression here would be a 4. Now we have that perfect square trinomial. So we've got here 3 times the quantity of x squared plus 4x plus 4, right? But on the other side, when we were adding it in, right? So if I added a 4 right here, this entire expression that this 4 is in is being multiplied times 3. So what we've really added to the right side would be 12. It would really be 12. So now that we've figured that out, we can simplify the left side. We'll have y minus 1 plus 12 will give us y plus 11. And then on the right side, we have 3. And our x squared plus 4x plus 4 should factor into x plus 2 times x plus 2, or we could write it as x plus 2 squared. Last step, we got to move the k value back over, so we'll subtract the 11 from each side. And that is our function in graphing form. Y is equal to 3 times the quantity of x plus 2 squared minus 11. And from there, it's really easy to find our vertex, right? Because that's our vertex form. We've got -2 comma -11. That's really easy to help us get the axis of symmetry because it's always going to be x equals the x-coordinate of the vertex. And so we have two things left to find. Well, y-intercept's pretty easy, right? In standard form there, it's always going to be equal to that constant term in the back, because when we put in 0 for the x's, we'll be left with 0 plus that 1. So we've got the y-intercept is the point 0, comma 1. And then the one that's a little bit more challenging at this point here is finding the x-intercepts. So let's just use our graphing form to practice doing that here. We're going to put in 0 for our y. So 0 equals 3 times the quantity of x plus 2 squared minus 11. And now we're going to solve this for x. We're going to add 11 to each side, which will give us 11 equals 3 times the quantity of x plus 2. I'm sorry, I don't know why I wrote a 3 in there. X plus 2 squared minus, nope, that's not even there anymore. All right, now we're all on the same page here, right? So now we're going to need to divide each side by 3. You must get rid of that a value before you take the square root. So 11/3 is equal to the quantity of x plus 2 squared. We take the square root of each side. And it's okay right now that we're leaving a fraction in the square root. We talked about earlier in the year that we didn't want to do that, but it's totally fine in this case. So we've got here the absolute value of x plus 2 should equal the square root of 11/3, which means that x plus 2 should end up equaling positive or negative radical 11/3. And then to get x completely by itself, we'll just subtract our 2. And we have negative 2 plus or minus the square root of 11/3 is equal to x. Like I said, not very clean and pretty. That's okay. And those are the answers. So we'll go ahead and do 2 and 3 because I know I asked you to do them at home, but I realize that it's probably going to be tough for you. So let's see here. We have y is equal to 2x squared plus 4x plus 1. Again, start the same way. Subtract the 1 from each side. We have y minus 1 equals 2x squared plus 4x. Remember, the next step is to factor out a. So this isn't the greatest common factor. It's just a that's being factored out. So we've got a 2, and then we've got x squared plus 2x. Nothing has happened to the left side yet. Now we will complete the square. All right, and then this is the other way we talked about how to find this value here with our secret formula, right? If we take our b term, remember it's b divided by 2 and then squared. We'll give you that same value that you were getting up in the right corner of the generic rectangle. So I'm going to take 2 divided by 2 and square it. That should give me 1. So we're going to add in 1 here. But remember, this 1 is being multiplied by this 2. So we've really added a total of 2. So we need to add 2 to the left side to keep it balanced. Now we'll just rewrite. We'll say y plus 1 is equal to 2. And then our trinomial here should factor into x plus 1 times x plus 1, or x plus 1 squared. And last step, get the k over on the other side here. So y is equal to 2 times the quantity of x plus 1 squared minus 1, our graphing form. Then again, we can find the vertex pretty easily from there. The vertex then would be -1, -1, the opposite of this number, and then our k value. Axis of symmetry, pretty easy then. X equals -1. Y-intercept that we have here, it looks like it's going to be +1, so we've got 0, 1. And then again, we'll need to find the x-intercept. We can take it and solve the graphing form of the equation for x. So we'll say 0 equals 2 times the quantity of x plus 1 squared minus 1. So we're going to add our 1 to each side. 1 equals 2 times the quantity of x plus 1 squared. We divide each side by 2. 1/2 is equal to the quantity of x plus 1 squared. Now we're going to take the square root of each side. And we're going to be left with, I'm going to move it up here just so I have save room on the next problem. But we have the square root of 1/2 is equal to the absolute value of x plus 1, which then tells us the positive or negative square root of 1/2 should equal x plus 1. And then we'll subtract our 1. We get negative 1 plus or minus the square root of 1/2. Now for this part here, I'm not going to make you rationalize your denominator or anything there. It's totally fine. Just leave it like that for now. That's not the skill we're working on, and I want to make sure we're not distracted by trying to do that part right now. So negative 1 plus or minus the square root of 1/2, comma, 0 are our x-intercepts. All right, there's 2 more here. I'm going to go ahead and do them. You can pause the video and work through them, then check to see if you're right. If you just want to fast forward through it and just copy it all down, I don't really care, to be honest with you. Get out of it what you need to. So number 3, we have y equals 3x squared minus 24x plus 42. Same first step. Let's take it here, subtract 42 from each side. Y minus 42 is equal to 3x squared minus 24x. Second step, remember, factor out the a. So we now have 3 times the quantity of x squared minus 8x. That still equals y minus 42. Now we're completing the square. So let's set our equation up to get our missing value here. So with this one, I'm going to use just that shortcut there, where we're going to take half of negative 8 and then square it. So half of negative 8 is negative 4, squared is 16. That is that missing value here. So we're adding 16 here. But again, we have 16 and we're multiplying that by 3, so we're really going to add 16 times 3, which would be 48 to the left side. So now it's y plus 6, after we simplify it, is equal to 3 times the quantity of x. And where does this number come from inside of here? Well, remember, if you were doing like the box, you would always take that 8 and split it. So you'd have like a negative 4x and a negative 4x, which means when you pull it out, you'd have a negative 4 and a negative 4. So this value here is always going to be half of what this one is in the trinomial. So we have x minus 4, that quantity squared. And then the last step, go ahead and subtract k from each side, so we get y is equal to 3 times the quantity of x minus 4 squared minus 6. From there, vertex would be 4, negative 6. Axis of symmetry then would be x equals 4. The y-intercept comes from over here. We've got 0, 42. And then we just need to find our x-intercepts on this one. So we'll take it and solve it one more time. 0 equals 3 times the quantity of x minus 4 squared minus 6. Add 6 to each side, so you've got 6 equals 3 times the quantity of x minus 4 squared. Divide each side by the 3. 2 equals the quantity of x minus 4 squared. Looking for a square root now. So now we've got the square root of 2 is equal to the absolute value of x minus 4, which then becomes x minus 4 equals positive or negative square root of 2. And then we just add our 4 to each side. So 4 plus or minus the square root of 2 is equal to x, or 2 x-intercepts there. All right, so we'll go ahead and just do this last one. Number 4 says y is equal to 1/2 x squared minus 6x plus 1/2. First thing to look at here, let's just go ahead and get rid of the 1/2 from each side. So we have y minus 1/2 is going to equal 1/2 x squared minus 3x. In this next step, when we factor here, right, we're going to factor out a 1/2, and we are going to be left with x squared minus, so when you divide 3 by 1/2, you should get 6x, and that should equal y minus 1/2. Let's complete the square now. 1/2 times the quantity of x squared minus 6x plus blank. And we have y minus 1/2 plus blank. Our missing value here, right, we can find it by doing -6 divided by 2 and then squaring it, which would be +9. We're going to add a 9 here. But remember, this 9 is being multiplied times 1/2. So on our other side, to keep it balanced, we're going to have to add half of 9. So we could say it's like 9 over 2. Well, 9 over 2 plus a negative 1/2 would give us 8 over 2, which really is just then 4. So we have y plus 4 is equal to 1/2. And then our x squared minus 6x plus 9, right, we're going to have x minus 3, that quantity squared. And last but not least, let's just move the k value over by subtracting the 4 from each side. So y is equal to 1/2 times the quantity of x minus 3 squared minus 4. Then vertex should be 3, -4. Axis of symmetry, x equals 3. Y-intercept here is positive 1/2. And our x-intercept we can find here by solving our graphing form of our equation. We'll say 0 equals 1/2 times the quantity of x minus 3 squared minus 4. Add 4 to each side. So 4 is equal to 1/2 times the quantity of x minus 3 squared. Let's multiply both sides times 2 now, right, to get rid of the 1/2. So 8 is equal to x minus 3 quantity squared. Let's take our square root. Now, if you want to break down the square root of 8 into 2 radical 2, you can totally do that. Or if you want to leave it as the square root of 8 for now, that's fine. I'm going to go ahead and do it since I know what it is. That's 2 radical 2 is equal to the absolute value of x minus 3, which means x minus 3 is equal to positive or negative 2 radical 2. And then in the end, after we add 3, we have 3 plus or minus 2 radical 2 is equal to x. 3 plus or minus 2 times the square root of 2, comma 0 is our x-intercepts. All right, so Hopefully this helped you out with the back a little bit. I know that we were a little pressed for time in class, so I wanted to make sure I tried to give you a little bit of direction here. We are going to practice this for a couple days. We've got some other stuff going on also, but we'll be practicing. So if you have questions, make sure you bring them to class. Thanks.